Bienvenidos, Ushamnid, and welcome Anne Arundel Community College learners from the CTS 130 Section 402 course for the spring 2021 semester. This is the Cisco Networking Academy's Introduction to Networks version 7 course curriculum, or the ITN v7, and in this packet tracer tutorial, we're going to be taking a look at skills challenge number 3. In other words, we have a custom packet tracer activity in which we have a number of configuration tasks we're going to need to complete on a router and a switch. And there's also some subnetting here that we'll be dealing with as well. So here is the activity, right? Very straightforward. We're going to be completing some device configuration on a router, a switch, and we've got some IP address assignment, which is going to require us to work a little bit with a /27 network as well as a /30 network. And so you can think of it like this. Here's my small office. This is my router for the HQ office. We have a switch connected to the router. It appears that everybody's going to be in VLAN 1 here, right? We haven't talked about creating VLANs yet and segregating and segmenting networks. So everything is on VLAN 1, the default VLAN. And then we have 4 PCs that maybe workers are using here. And then we have a connection out to our service provider. So let's go ahead and dive in. And again, the beginning of this activity, the first few steps up into the subnetting, this is kind of old hat for us now, right? So we are about 4.5 weeks into the course. So some of the basic configuration, like the host name, right? These things should be pretty straightforward. So we'll say hostname HQ. We're going to disable DNS lookups, no IP domain name lookup. We're going to put a banner message of the day in here. Now, remember, when I say banner MOTD and then I do a question mark, you can see it says C. It shows that little lowercase c there as a delimiting character. I want you to think of that as like a bookend. And the question came up in our Zoom session about the $sign. Remember, you can use just about any character you would like to start the message of the day on the left-hand side. And then, you put your message of the day in here, and then you end the message of the day. And basically, again, think of those $signs or the delimiting character as sort of double quotes, right? You're enclosing the quote. You're enclosing that banner message of the day so that iOS knows this is where it starts, the message of the day, and here's where it ends. And so we'll use the $sign here. So we're going to say warning, authorized, access only. Now you'll notice it says use exact wording and punctuation. If we don't, we're probably not going to get credit, but we did pick up the point there for that. Now, this is a command, this next one, minimum password length of 8. This is something you can do on routers, but you can't do on the switches. And so it's going to be a security setting. Security. It's going to be a security setting with the passwords, minimum length, and here we put in the minimum length of the password that we're going to be able to use, and it's going to be 8. So security, passwords, minimum length, 8. Now, an encrypted privilege exec password of Cisco 123. So we're going to say enable, we're going to say enable, and again, we have 2 choices here, secret or password. We know password is not going to give us what we're looking for here, and that we want the secret. And so our privilege exec password will be Cisco 123, and there we have 8 characters, so we meet that criteria of having 8. All right, so we've got the enable secret password. Let's look back up here. So console and VTY access password of class 123. So we've done this multiple times, line con 0. Now remember, if we're going to put the password there, we want to make sure that we put our login statement there, right? And you can see here, it says login disabled on line 0 on the console line until we set the password of class 123. And then we'll say line VTY 0 to 4. We'll say login, which is probably already there. Let's say do show run. And get down here to the bottom. You can see login is already there, right? So if we type it again, and it's going to basically say that it's disabled until we say password class 123. All right, so if I say do show run section line con, There's our console line, and then do show run section, and you could say line VTY or VTY. And so those match up and everything looks really good there. So we're going to encrypt all plain text passwords. So this is our service password encryption. Now we get into the IP addressing. So let's get into that Gigabit Ethernet 00 interface, and let's say no shut right out of the gate. And you can see that that is our LAN facing interface here, right? Because we now have the link coming up. In fact, if I wanted to, I could do the little fast forward arrows, right? Click it a few times and it speeds everything up so that we're not waiting for it to move into the forwarding state. Again, we're kind of waiting for spanning tree there, a topic that we'll be talking about as we move through into the next couple of courses. So now it's asking me to assign the first usable IP address and subnet mask in the 192.168.1.0/27. And so we've done this a number of times as well. So we should be able to look at this, and using that little order of operations, we say, okay, well, this is by default a Class C address with a default subnet mask of 255.255.255.0. Right? So the first 24 bits by default for a Class C address are representative of the network portion of the address. And the last 8 bits are representative of the host portion. Now let's break out these 8 bits. So we have 1, 2, 3, 4, 5, 6, 7, and 8. I'm just going to put underline, little underscores here for now, because we're borrowing from these 8 bits, the host bits. We're borrowing the host bits to make them network bits. Well, if the first 24 bits are already spoken for and we're a /27, we take 1, 2, 3 network bits, leaving 1, 2, 3, 4, 5 host bits. Right? So pretty easy way to look at it. So now I know how many subnets did I just create out of this single 192.168.1.0/24. We subnetted it down, so we have 2 to the 3. So I just created 8 total subnets. Well, how many... Or first, then the next question would be, what is my block size? Well, remember, the block size is 2 raised to the number of host bits that remain after we borrow our network bits. Again, we want more networks with fewer hosts. That's why we subnet. So we take a look at this, and we say 2 to the 5 is 32. And so my block size, and we'll say BS, the block size is 32. How many usable, assignable host IPs do I have? Well, we subtract 2, 1 for the network ID and 1 for the broadcast address. And right there, in all of about 60 seconds, we figured out the number of subnets, and I'll just put S for subnets, the block size, and the assignable IPs. So we have everything we need right now to be successful in taking care of this information. And how would we do that? Well, fortunately, they're allowing us here to start at the .0. So I would say .0, and the next subnet over would be block size .32, and then the next one would be plus 32, so 64, and then 96, right? And we don't have to do all of these, but I'm just drawing it out so that you can see that now I have the subnet that we're interested in. The last thing we need is the dotted decimal notation for the 4th and final octet, which would be 128 right here, plus 64 is 192, plus 32 is 224. And that is everything we need at this point. I'm not going to erase that. I'll leave that up there in order to configure the router. And so let's go ahead. It says assign first usable IP address and subnet mask in the 192.168.1.0/27 network to this interface. So we're going to say, we said no shut. I'm going to say IP address 192.168 dot 1 dot what? What would be the first usable IP? Yeah, dot 1. And the subnet mask, 255, 255, 255, 224. And you can see we picked up a few points for that. Now, description, right? So we're going to put a description in here. We're going to say connection, whoops, spell connection right. Connection to switch 1. And so we've got our description in there. Now we're going to get into the serial 000 interface. And now we've got another subnetting question that we're going to have to answer here. But again, we should be pretty well versed in this at this point, especially when we're taking a look at a /30, right? Anything above a /24 is very straightforward to deal with because we're only focused on that fourth and final octet for doing our borrowing. So what I'm going to do is we're going to drag a little arrow down here, and this is going to be for that 209.165. So you can see it's a /30. And again, the first 24 bits, and I'll just do it like this. We'll say 8 bits, 8 bits, and 8 bits are already spoken for in our subnet mask here, and now we're going to subnet it down to a 30. So if the first 24 bits are taken, I need 6 bits out of the last octet, 3, 4, 5, 6, 7, 8. So I need network bit, network bit, network bit, and you see what we're doing here? Whoops, network bit, meaning I only have 2 host bits left, because if it's a /30, the first 30 bits going from left to right are going to represent the network portion of the address, meaning, because we've got this 209 address, that these 6 bits, and I'll draw a little divider here, these 6 host bits that were here are now network bits because we want more networks than we want hosts. This is a point-to-point serial connection. There will only ever be 2 things on either end of this serial cable. So why not right-size the network so that we get 2 usable host IPs? And so again, I've got 6 bits here. So 2 to the 6, how many subnets did I just create? Well, 2 to the 5 is 32. So I just created 64 if we're doing fixed length subnet masking. I just took this 209.165.200 and I just created 64 subnets. The first one will be .0, but what's the second one? I need the block size. Well, how do I get the block size? Well, we take the number of host bits, and I'll drop that down here, and we raise it, or we say 2 to the number of host bits that remain, and that is 4. How do I get the usable IP addresses for each of these 64 subnets? Again, assuming we're talking about fixed length. I subtract 2, and take a look at that. We end up with 2 usable IPs. So my block size is 4, meaning it would be starting with .0, .4 is the next subnet ID, .8 is the next subnet ID, .12 is the next subnet ID, so forth and so on. And then we'll draw the little line here. And so if 4 is the next subnet ID, my broadcast address is going to be .3, and my 2 usable IPs will be .1 and .2. And there we have it. It's that simple. Now, what about the subnet mask in dotted decimal notation? Well, to get that, we simply add up the network bits here in the last octet for each of their bit values. So 128 plus 64 is 192, plus 32 is 224, plus 16 is 240, plus 8 is 248, plus 4 is 252. All right, so now we have everything we need to answer this serial question. So let's first say no shut, and you can see there is no spanning tree in play there. The link comes up immediately because there's no switch involved. So let's go ahead now and assign the second usable IP address in that ISP network. Well, the second usable we know is going to be IP address 209.165.200.2. And our subnet mask in dotted decimal notation is 255.255.255.252. Now our description is going to be connection to ISP. And we already enabled the interface, and so we're good to go there. So let's go ahead, and in that, we'll do a quick write mem here. And you can see we're at 18 out of 45 points right now. And so now let's come over to our switch, right? Because we've got some work to do here on the switch. And again, these first few commands, right? Hostname, S1, no IP, domain, lookup, right? We should be very well versed with those commands at this point. So same with the banner MOTD, banner message of the day. And here I'll use a % as the delimiter. Again, as long as I'm not using the character in the message of the day string, authorized access only, exclamation mark, it's just like bookends, right? Everything between my delimiters, here the %, that is my message of the day. All right, so let's encrypt our encrypted privilege exec password. So we're going to say enable secret, and it's going to be Cisco123. And then we want console and VTY access password. So let's go ahead and say linecon0. And I forgot we should probably put in here logging synchronous as well. We'll say login, and then we'll say password class123. And then we'll say line VTY 02, and I'm assuming there's probably 15 here. Let's say do show run, and then section VTY. Yeah, so line VTY 0 to 15. We'll say login password, and you can see it's going to disable it until we put the password in here of class123. And then we'll say logging synchronous, although we're not actually going to be remoting in here via SSH or something like that. All right, so that takes care of the console. Let's encrypt all plain text passwords, right? Service, password encryption. Now, default gateway with HQ's gig 00 IP address. And so on the switch, remember, the switch is just like any other PC laptop in the sense that if it's generating traffic and it doesn't know where to send it, it needs the default gateway. 192.168.1.1. And let's assign the second usable IP address in that 192.168.1.0/27 network to the SVI. So interface VLAN 1, let's say no shut right out of the gate. And we'll say IP address, and we're going to do the second usable IP, which would have been .2, 192.168.1.2. And remember, it's a 224 for our subnet mask length. And we've already activated it. So let's go ahead and say write mem. We've got 33 out of 45. So now it's a matter of dealing with the PCs. And so specifically what we're going to do here is you can see it's going to ask us to put the PC addresses based on the subnetting information. I can leave that right there, in fact. So PC 0 gets the third usable IP. So 192.168.1.3. And our subnet mask, and all we have to change is 224. And then we'll put in our default gateway, 192.168.1.1. And now let's pull up PC1, and PC1 is going to look very similar. It's going to use the fourth usable, 192.168.1.4. We simply change that to 224, and then we change our default gateway, 192.168.1.1. Let's do PC2, and we'll go ahead and pull our desktop and our config up here. Now, PC2, it says the second to last usable. And so this might be require some thinking here. So 192.168.1, well, the second to last usable. Well, the last usable is 30. The next to last would be 29. And so then I believe if they're saying the second to last, they're looking for 28, and we'll be able to tell on our percentage. So we've got 39 out of 45. And let's see if they like what we do here. And they did. Okay, so 192.168.1.1. And then last but not least, the last usable IP is going to go to PC3. So 192.168. Whoops, let's pull that back. 192.168.1.30 is the last usable. And 224. And we've got our default gateway, 192.168.1.1. All right, so we've got 44 out of 45. Assign the appropriate default gateway on each PC. The last usable. Ensure that all PCs in Switch 1 can ping the default gateway address on HQ. Now, I don't believe they're going to give us points, so let me make sure that I'm not missing anything here. PC2 IP address. All right, so it does not like the, oops, sorry, I'm going to close this out. It doesn't like the IP on PC2. Let's see what we might have done there that it didn't like on PC2, and my activity has disappeared here. So let's see where the activity has gone. All right, so the activity has disappeared, and it didn't like the PC2 IP. So let's see what we've got here. There's PC0, PC3, and PC2, oh, was second to last. So maybe it's looking for second to last usable. Well, second to last usable should be the 28. Let's see if that was it. There, okay, sorry, it must have been 29 was what they were looking for. All right, so again, how can we test this? Well, we don't even need the activity at this point, right? So I can close this down, pull the command prompt up, and let's throw a ping out there, 192.168.1.1. Everything looks good there. Let's come down here to switch one, ping 192.168.1.1. Whoops, and let's type that correctly. And there you have it. All right, so that is going to do it for this activity. Let's clear our screen here. Let's drop that out of the way. And so that's it for our skills challenge number 3. Again, definitely some challenging wording on PC2, or some challenging thinking required on PC2 to figure out that that IP should have been 192.168.1.29. All right, thanks so much for watching, and I hope to see you guys in the next video.